Welcome back, everyone, to the Deep Dive. Ready to explore some cutting-edge stuff.
Always.
Today, we're diving into DeepSeek-V3. It's making waves in the world of open-source large language models.
I've heard some buzz about this one.
Yeah, and we've got the DeepSeek-V3 Technical Report right here with us, so we can really get into the nitty-gritty.
Excellent.
This model is really interesting, especially because of its performance with code and math.
And it's incredibly efficient from what I've gathered.
Yeah, the efficiency is remarkable, even for an open-source model.
Woo, let's not waste any more time. Let's dive in. What's the headline?
Okay, so DeepSeek-V3, it's a mixture of experts, or MOE, model. And get this, it's got 671 billion parameters.
Wow.
But here's the kicker. It only uses around 37 billion for any given token.
So it's sort of like a specialized team then.
Yeah, exactly. It's like having this huge team of experts, but only calling on the ones you need at any given time.
Clever. So that's how they achieve such great efficiency.
It's a big part of it. And this is especially important for, researchers and developers who might not have access to, like, Google-level computing power.
Right. Democratizing access. Makes sense.
They also highlight some really interesting architectural innovations in the report. One of them is multi-head latent attention, MLA.
Okay, I've skimmed the report, but tell me more about this MLA. How does it work?
Well, it's all about being smart about memory usage. They're really selective about what gets cached in the key value cache.
Ah, interesting. So they're not caching everything.
Exactly. Only certain elements like TD-TV and KTR.
So like a condensed version of the essential information.
Right. And this selective caching, it helps to make inference much more efficient.
So that's one way they're addressing the efficiency aspect.
Yeah, and then they also have this DeepSeek MOE architecture, which really takes advantage of the MOE approach.
I'm curious about that because it sounds like they've pushed the MOE concept further in some way.
Yeah, it's more than just using MOE, right? They actually use finer-grained experts.
Ah, I see. So the experts are more specialized.
Exactly. Each expert handles a much narrower domain.
Yeah.
And that allows DeepSeek-V3 to be super knowledgeable without needing to activate all 671 billion parameters all the time.
I'm starting to see the bigger picture of how they achieve such efficiency. It's really impressive.
Yeah, it is. And then they've got this other concept, shared experts, which are accessible to all tokens.
So even with all the specialization, there's a common ground.
Exactly. This helps DeepSeek-V3 handle common language patterns efficiently without always having to call on those specialized experts.
Very interesting. Now, the report also mentions something called auxiliary loss-free load balancing.
Yeah, that sounds pretty technical, I know.
Well, load balancing is obviously important in a MOE model, right? Making sure the workload is spread evenly.
Right. You don't want some experts working overtime while others are just sitting there.
Exactly. So how does this auxiliary loss-free part come into play?
Well, traditionally, load balancing in MOE models often uses auxiliary losses.
Right, to encourage that even distribution of workload.
But the problem is, these auxiliary losses can sometimes hurt the model's performance.
So it's a bit of a trade-off.
Yeah. But DeepSeek-V3 has this clever way of doing it without relying on those auxiliary losses.
How so?
They use a bias adjustment technique to guide the routing process.
Ah, I see. So they're nudging the system towards balance without using those potentially harmful auxiliary losses.
And they've managed to maintain both efficiency and accuracy with this approach.
Quite an accomplishment.
Now let's talk about another interesting idea they introduced. Multi-token prediction, or MTP.
This one caught my eye as well.
So typically, language models just predict the next token in a sequence.
Right, one step at a time.
But DeepSeek-V3, it tries to predict multiple future tokens all at once.
Wow, so it's thinking ahead.
Yeah, and what's really cool is that it maintains this full causal chain for predicting each of those tokens.
So it's not just guessing randomly, it's actually reasoning about the sequence in a more sophisticated way.
Exactly. And this approach has the potential to lead to more accurate predictions and faster decoding down the line.
That's fascinating. I'd love to see how that plays out in practice.
Now let's move on to the training process. DeepSeek-V3 was trained on a massive cluster of 2048 NVIDIA H800 GPUs.
That's some serious hardware.
Yeah, it's a lot of power. But the hardware's only part of the story.
Right.
What's really interesting is how they optimize the whole training process.
Exactly.
So they developed this thing called the dual pipe algorithm to maximize pipeline parallelism.
Okay, I'm familiar with pipeline parallelism, but refresh my memory on what dual pipe brings to the table.
So pipeline parallelism is all about splitting the training process into stages, with each stage running on a different GPU.
Right, like a factory assembly line.
But with traditional pipeline parallelism, you often get these pipeline bubbles, where parts of the system are idle, waiting for data.
Bottlenecks, classic problem.
Exactly. The dual pipe algorithm is super clever. It overlaps computation and communication between those stages.
Ah, I see. So it's keeping those GPUs busy all the time, minimizing the downtime.
Right. It's like a perfectly choreographed dance. And this makes the training process so much smoother and faster.
Very elegant solution.
They didn't stop there. They also created these custom communication kernels to optimize the data transfer between the GPUs.
Yeah, communication overhead can be a real killer in distributed training.
Exactly. So they basically streamline the traffic flow between those GPUs, making sure everything moves quickly and efficiently.
Makes sense.
Now, another really big highlight of the report is their use of FP8 mixed precision training.
Ah, this is something I wanted to ask about. It's still relatively new, isn't it, using FP8 for training these massive models?
Yeah, it is. DeepSeek-V3 is actually one of the first to successfully use FP8 at this scale.
So using fewer bits to represent the numbers.
The challenge is maintaining accuracy.
Right, because using fewer bits can introduce errors.
Exactly. But DeepSeek-V3 tackles this problem with smart quantization strategies.
So they're finding ways to compress the information without losing the important details.
Yeah, and they also use this technique called increased accumulation precision. And all of this ensures that they can benefit from the efficiency of FP8 without losing performance.
Really impressive stuff.
And all of this while training on this massive data set. 14.8 trillion high-quality tokens, to be exact.
Wow, that's a lot of data.
Yeah, it includes English, Chinese, and other languages too. And they really focused on including lots of math and programming samples, which I think explains why DeepSeek-V3 is so good with code and math.
Right. It's like giving the model a specialized education in those fields, tailoring the data to the desired outcomes.
Exactly. And speaking of specialized training techniques, they also use something called the fill in the middle, or FIM strategy.
I've heard of this one. It's about context, right?
Yeah. Instead of just predicting the next token, DeepSeek-V3 is trained to predict missing elements within a sequence.
So it's forced to consider the surrounding context.
Exactly. It's like filling in the blanks in a sentence. And this is really valuable for things like code generation, where understanding the bigger picture is crucial.
Absolutely. So they've got this powerful model, pre-trained on a massive data set, with all these clever techniques for maximizing efficiency. What's next?
Well, they didn't stop there. They actually go through 2 stages of post-training to refine DeepSeek-V3 even further.
Intriguing. Let's dive into those post-training stages in part 2 of our deep dive.
Sounds good to me.
So let's talk post-training. What's the first stage they use to refine DeepSeek-V3?
The first stage is supervised fine-tuning, or SFT. It uses a massive data set of 1.5 million instruction tuning examples.
Okay, and what's the goal of this fine-tuning stage?
It's all about aligning the model's output even more closely with human preferences.
So teaching it to follow instructions, generate the desired types of responses.
Exactly. And they did something really clever in creating this data set.
Oh, what's that?
They actually used another DeepSeek model, DeepSeek-R1, to help generate some of the data.
Wait, so they're using one AI to train another?
Yeah, exactly. DeepSeek-R1 is specifically designed for reasoning tasks.
So they're leveraging the reasoning capabilities of one model to enhance another.
Right. And it's not just DeepSeek that's doing this, by the way. This technique is becoming more common in large language model research.
Makes sense. It's a way to create these massive, high-quality data sets without solely relying on human annotation.
Which can be super time-consuming and expensive.
Absolutely. Okay, so they've fine-tuned it with this hybrid data set. What's the second post-training stage?
The second stage is reinforcement learning, or RL.
Classic RL. The model learns through trial and error, getting feedback on its outputs.
Right. It receives rewards for good outputs and penalties for bad ones. And over time, it learns to maximize those rewards.
So how did they set up the reward system for DeepSeek-V3?
They used a combination of rule-based and model-based reward systems.
Interesting. So rule-based systems, those are the more objective ones, right? Based on predefined rules. Like if the model gets the right answer to a math problem.
Yeah. And then model-based systems, they use another AI model to evaluate the output.
Ah, so it's a more nuanced kind of feedback, more like having a human judge assess the quality.
Exactly. And they didn't just use any old reward system. They actually incorporated knowledge distillation from DeepSeek-R1 into this process too.
So that reasoning expert is back again.
It helps DeepSeek V3 learn to think like DeepSeek R1, further boosting its reasoning capabilities.
Clever. Did they encounter any challenges during this RL stage?
Yeah, actually, they observed an interesting trade-off between reasoning performance and response length.
Yeah, the more reasoning it did, the longer the responses tended to be.
Exactly, a classic challenge with LLM.
Finding that balance between being comprehensive and concise.
Right. But the performance gains they achieved through RL, they're pretty remarkable.
I'm eager to hear about those results. How does DeepSeek V3 stack up against other models out there?
They evaluated it on a wide range of benchmarks, from question answering and language understanding to code generation and math.
So a pretty comprehensive evaluation.
Yeah, and the results are super impressive. DeepSeek V3 consistently outperformed other open source models across the board.
And how about compared to those closed source giants like GPT-4o and Claude?
Well, it even rivaled, and in some cases surpassed, those models on certain tasks.
Wow, that's a big deal, especially considering how much they focused on efficiency with DeepSeek V3.
Right. It's a big win for open source AI. It's setting a new standard for what's possible.
Absolutely.
So they used a bunch of different benchmarks. What were some of the highlights for you?
Well, as expected, DeepSeek V3 really excelled in the math and coding tasks. Benchmarks like Human Evil, MBPP, and Live Code Bench for coding, and GSM-8K, and Math for math, it just blew the other models out of the water.
Yeah, all that specialized training really paid off.
It did. So beyond the raw performance numbers, what are some of the big takeaways from this report? What does DeepSeek V3 tell us about the state of open source AI?
I think DeepSeek V3 represents a major step forward. It shows that you can achieve state-of-the-art performance with an open-source model. And that's huge for researchers and developers who might not have access to those massive resources that the big tech companies have.
It's democratizing AI, in a sense, lowering the barrier to entry for working with these powerful tools.
Exactly. And that has the potential to unlock all sorts of new innovations across different fields.
I completely agree. It's an exciting time to be in this field. And this report from DeepSeek, it's not just about the technical achievements, it's also about thinking responsibly about the future of AI.
Oh yeah, they dedicated a good chunk of the report to discussing the ethical considerations, which I thought was great to see.
It's a sign of maturity, I think, recognizing that these models have the potential for both good and harm.
And it sounds like DeepSeek-AI is committed to figuring out how to ensure that these models are used for good.
Definitely. They're pushing the boundaries, but they're doing it thoughtfully. So what's next? What are they looking to improve or expand upon with DeepSeek V3?
They highlighted a few areas in the report. One is addressing that trade-off between reasoning performance and response length that we talked about earlier.
Yeah. Making it more concise without losing the reasoning depth.
Right. They're also looking at refining the FP8 training framework.
Trying to squeeze even more efficiency out of it.
Yeah. Always iterating, always improving.
That's the spirit. Now, I'm curious, did they mention any specific areas where they see the potential for DeepSeek V3 to really make a difference, like real-world applications?
Well, they didn't go into specific applications, but they did talk about the broader impact that they hope DeepSeek V3 will have. They see it as a platform for innovation, enabling all sorts of new possibilities in different fields. They even hinted at some really futuristic ideas, like training LLMs on images and audio, or even combining different data types.
Multimodal learning? That's fascinating. The possibilities are really endless, aren't they?
It feels like we're just scratching the surface of what these models are capable of.
Yeah. It's an exciting time to be working in this field. So much potential for positive change, but also a lot of responsibility to ensure that this technology is used ethically and for the benefit of all.
Absolutely. This has been a really insightful deep dive into DeepSeek V3. I'm really glad we had the chance to explore this together.
Me too. I feel like I have a much deeper understanding of this model now. What do you say we wrap up this deep dive with a look at some of the limitations they mention and potential future directions?
Sounds like a great plan.
So you mentioned limitations and future directions. Where do they see room for improvement with DeepSeek V3?
Well, they highlighted a couple things in the report. One is that trade-off between reasoning performance and response length that we talked about earlier. You know, how the more deeply the model reasons, the longer its responses tend to get.
Right. It's a classic challenge. So what are they thinking in terms of addressing that?
Yeah. They're exploring different techniques to enable DeepSeek V3 to provide more concise and focused responses without sacrificing the depth of its reasoning. So it's about being both smart and efficient in how it communicates.
Makes sense. Any other areas they're looking at?
Yeah, they also pointed out some aspects of their FP8 training framework that could be further optimized. They specifically mentioned needing higher precision in certain FP8 computations and wanting better support for really fine-grained quantization within the hardware itself.
Ah, so they're bumping up against some of the limitations of the current hardware.
Yeah, it seems like it. They actually had some suggestions for hardware vendors, like offloading certain communication tasks to dedicated hardware. That could free up the GPU's core processing units to focus on more complex computations, potentially leading to significant performance gains.
Interesting. So essentially co-designing the hardware and software to maximize efficiency.
Exactly. And they also proposed implementing things like tile and blockwise quantization directly in the hardware, which would streamline the training process even further.
Makes sense. It's a reminder that AI advancements like DeepSeek-V3 aren't just about algorithms and data. They also drive innovation in hardware.
Absolutely. It's a constant back and forth, each pushing the other to evolve and improve. This whole discussion about DeepSeek-V3 and its open source nature,
Yeah.
it brings up that bigger debate about open source versus closed source AI.
Definitely. DeepSeek-AI is making a strong statement here with DeepSeek-V3. They clearly believe in democratizing access to powerful AI technology. But, as you said before, it raises those important questions about responsible development and use.
Right. How do we ensure these incredibly powerful tools are used ethically and for the benefit of everyone? It's a tough question.
No easy answers, that's for sure. Open source has the potential to fuel amazing innovation, but there's always the risk of misuse.
It seems like DeepSeek-AI is very aware of those risks. They dedicated a lot of space in the report to discussing ethical considerations.
Which is good to see. They're not shying away from those tough conversations. It's a sign of responsible development.
Definitely. Now, before we wrap up, I wanted to circle back to a couple of those innovations in DeepSeek-V3 that we talked about earlier. That multi-head latent attention, or MLA architecture, is really key to the model's efficiency. Could you remind us again how it works?
Sure. MLA is all about optimizing how information is stored and retrieved within the model. LLMs deal with massive amounts of data, and so managing that efficiently is crucial for performance. MLA achieves this by compressing the key value cache. Essentially, it's creating summaries of the most important information.
So instead of storing every single detail, it intelligently prioritizes what to keep readily accessible.
Right, and they specifically mentioned only caching certain elements, CTKV and KTR, which keeps the memory footprint smaller.
Now, for those who might not be familiar with those terms, could you break them down a bit?
Of course. So, CTKV is a compact representation of the attention keys and values for a given token. It encodes the relationships between that token and others in the sequence.
Okay, and what about KTR?
That's the key that holds the rotary positional embedding, or ROPE information. ROPE basically encodes the position of a token within the sequence.
Which is crucial for understanding language. Words have to be in order for the meaning to be clear.
Exactly. Without positional information, the model would just have a jumble of words. So yeah, MLA is really clever in how it compresses all that essential information.
Now, another key innovation is that DeepSeek-Mo architecture. How does that differ from more traditional mixture of experts models?
DeepSeek-Mo brings a couple of new things to the table. First, they use finer-grained experts. So each expert is specialized in a much narrower domain of knowledge.
It's like having a team of specialized doctors instead of just one general practitioner.
Right. And this lets DeepSeek-V3 tap into this huge pool of expertise without having to activate all of it at once.
That's efficient. What's the second innovation?
They introduce shared experts, which are accessible to all tokens regardless of how they're routed. This ensures the model can handle common language patterns without calling on those specialized experts for every little thing.
So it's got both specialists and generalists, depending on what's needed.
Exactly. It's a really clever combination.
It is. And all of this builds on that auxiliary loss-free load balancing that we talked about earlier. Just to touch on that again briefly, why is that so important for performance?
Load balancing is crucial in MOE models. It's about making sure that the workload is evenly distributed among all those experts. If some experts are overloaded while others are sitting idle, you get bottlenecks. Everything slows down.
Right, it's like trying to get a big project done when only a few people are actually working on it.
Exactly. And traditionally, load balancing in MOE models has relied on these auxiliary losses. But those can sometimes hurt the model's performance.
It's like forcing people to work at an unnatural pace.
Yeah.
It might seem efficient, but it doesn't always lead to the best results.
Right. DeepSeek-V3 gets around this by using a bias adjustment technique. They're able to achieve balanced load distribution without relying on those potentially harmful auxiliary losses.
It's all about working smarter, not harder. And that really seems to be the theme with DeepSeek V3, right?
Absolutely. It's a testament to their ingenuity and commitment to efficiency.
Well, we've covered a lot of ground today in this deep dive into DeepSeek V3. From its unique architecture and efficient training process to its impressive performance and those really important ethical considerations. What are your final thoughts?
I'm really impressed with what DeepSeek-AI has accomplished here. DeepSeek V3 is a major achievement. It sets a new standard for what's possible with open-source LLMs.
I agree. It's not just a powerful tool, it's a symbol of what can happen when we make these technologies more accessible and open to everyone. And it's clear that the DeepSeek team is committed to doing this responsibly, which is really encouraging.
Definitely. They're not just pushing boundaries. They're thinking deeply about the impact this technology will have on the world.
And we encourage everyone listening to dive deeper into the full DeepSeek V3 technical report. It's a fascinating read. Lots of technical details and insights for those who want to explore further.
It's a must-read for anyone interested in the cutting edge of AI.
Well, on that note, I think it's time to wrap up this deep dive. Thank you for joining us on this exploration. Until next time, keep learning, keep exploring, and keep diving deep.
I'll see you next time.